Hey, what's going on, everyone? It's Max, and today I want to talk about writing papers. No, that might sound like a boring topic, but at the end of the day, whether it's for school or work, we all eventually have to do it. The typical go-to application people usually use to write papers is Microsoft Word. And while for simpler applications, this can usually get the job done, the moment you move to some larger, more complex task that really needs to maintain consistency and a really professional look throughout, LaTeX is the way to go. And in this video, I'm going to give you my personal 5 reasons why you should use LaTeX over a traditional word processing app like Microsoft Word. Number 1, a professional appearance. LaTeX documents often have a more professional and overall better look than documents written with traditional word processing applications. This is due to the fact that when you're writing in LaTeX, you have much more control over the typesetting of the document. The typesetting refers to things like word spacing, margins, figure placement, equations, formatting, things like that. LaTeX also has lots of features for making your own custom templates and structures, and I'll talk a little bit more about that later in the video. Here's a quick example of a document I wrote in LaTeX for work. This isn't the fanciest document I have, but I'm kind of limited to what I can show you from at least from things like work due to intellectual property in the papers. But here's a simple document showing how to solve for coefficients when designing a PID controller. And you can see the formatting is really nice. The equations look really good. There's also other little things that are really easy to implement. Like, for example, here's like a degree C symbol, adding figures, and also here's some nice like inline math as a fraction as well. So like this is stuff that is really hard to do in something like Word and also really hard to make look good in something like Word. Number 2, automatic reference numbering. Whenever you're writing professional or academic documents, it's pretty common that you'll have things like equations, tables, figures, things like that. And usually you'll want to assign some sort of like numeric designator to each one to help guide your reader to where that thing is. And it's always usually better to assign some sort of absolute reference designator, like a number, instead of a relative designator, like saying, see the equation below. Because if you're editing your document and you start moving stuff around and you say something like, see equation below, and now all of a sudden the equation is not below that sentence, it can look bad and also just confuse the reader. And the same problem can still happen when you're using numbers for references as well. You might have a set of references in a particular order. For example, in this case, like equation 1 followed by equation 2. And then while editing your document, you might move stuff around and forget to adjust the numbers accordingly. So you might have equation 2 come before equation 1. LaTeX solves this problem by using a variable like reference instead of something like an absolute number. And this variable like reference will follow the equation or table or figure wherever it is in the paper. And then at compile time, LaTeX will figure out the correct order of the numbering. Let's go over a quick example to illustrate this a little better. Here's the original sort of source file that generated the example document we were looking at just now. And here's sort of the source code, for lack of a better word, and then here's a preview of the document. And as we can see, we have something called equation 1 and equation 2. Namely, the quadratic formula is equation 1 followed by the Fourier transform for equation 2. And in the source over here, there's nowhere where we actually say equation 1. Instead, we say equation, and we have this /ref and then some text in here. And I'm just using the convention EQ for equation and then colon and then some abbreviation to describe the equation. And that's a label that I was able to attach to this entire equation. And likewise for the Fourier transform, I gave it a label of EQ colon capital FT, and that's a label attached to this entire equation as well. So in the preview, we have the quadratic formula as equation 1 followed by the Fourier transform as equation 2, but I can just copy the entire Fourier transform section and cut and paste it above the quadratic formula. Say I'm editing the document and I'm rearranging some content. I can recompile this now, and now the Fourier transform section's on top, the quadratic formula section's on bottom, and the numbering has been automatically adjusted to still be correct. Number 3, LaTeX source files are just text files. So this reason might sound a little bit silly, but just hear me out first. One thing that's really nice about text files is how simple they are. You don't need any sort of fancy application or program to open them. All you need is a basic text editor like Notepad. So you might be asking, well, so what? And my response to that would be, Well, you know what else is also a text file? All source code. So whether it's a .c, C++, .py for Python, Java, C#, MATLAB, whatever, all source code at its core is just a .text file. And the observation we can make here is to ask ourselves, well, how do software developers manage, keep track of changes, and save their code? Well, they use version control, and what's really popular now is Git. So what's really nice about LaTeX files being text files is that we can also use Git to manage, keep track of our changes, and save our code as well. And let's go over a quick example just to see this in action. So here's our example LaTeX file again, and let's just add a sentence. So new section will go here. And we can save our document.txt file. And now we can go to Git, and we can see that we've added a new line, and we can do just a regular Git commit as you would if you're just pushing code. So we can say adding new section, commit to the main branch, and then push the change. And now we can go to GitHub and actually, just like any piece of source code, see a history of all the changes made to this document. And right now there's only been 2. I had my first initial commit just to push it to the repo. And then here's the actual thing we just committed, adding our new section. Number 4, community. LaTeX has a really large community. So if there's ever anything you need, there's usually someone out there willing to help. I personally like to look for templates on overleaf.com when I'm starting a new project. Or if I'm running into some issue where my paper won't compile for some reason, I can usually go to the LaTeX site on Stack Exchange to find someone who can answer my question. I'd like to go over 2 examples of content I've been able to get from the community to help improve my projects. The first is in this example paper we have here for this bubble sort algorithm. So LaTeX has a built-in algorithm environment for creating content like this, but they don't have a for loop. So they have things like while loops and if statements, but they never had a for loop natively. And so some LaTeX user extended the algorithm environment to add for loops. So I was able to download their package and then make my implementation of bubble sort the way I wanted with the for loops included. The second example I want to show is applicable to almost everyone, and that is a resume. So before I started using LaTeX, my resume looked something like this. And this is what you'll find if you just go out and Google resume template. And so this is what my resume used to look like. And then what it now looks like because of LaTeX is this. As you can see, this resume is much more bold, much more interesting to look at. And if it was in a pile of a bunch of other resumes like I just showed you, this one would probably get picked up first. Number 5, it's free. Last but not least, LaTeX is totally free. All you need to get up and running is a distribution and an editor. And while not all editors are free, there's tons of great options out there. I personally use what's called MiKTeX for the distribution I'm using, and then my editor is called TeXStudio. TeXStudio is a really great editor, and I really like this 3-panel interface where this first panel on the left is sort of your table of contents. The middle panel is where you write your content, and then the far right panel is a preview of the final rendered document. Another nice feature about TeXStudio is that if you were to just like copy and paste some template online, there might be some of these packages that they have. Normally, you might not have these packages necessarily installed, but TeXStudio is smart enough to recognize if you don't have one of these packages installed, and it'll go out in the web and look for it and just download it for you automatically. And that's it. Those are my 5 main reasons why you should consider using LaTeX. Now, I'm not going to try and hide the fact that LaTeX does have a bit of a learning curve. And for your first several documents you write, you're probably going to feel less productive than you normally would. But that said, once you get the hang of it, I think you'll really start to enjoy it. And I think you'll probably even end up being more productive writing future documents. And I can honestly say that now at work, I've completely 100% switched over to using LaTeX over things like Word. And I think the only time I ever actually use Word at work is if someone happens to send me a Word document and I just need to open it and read it. And that's it for the video. Thank you all for watching, and I'll see you all next time. Bye.